Hi friends, my name is Noshad. Welcome to my YouTube channel. Today I am going to discuss about the oxy acids of phosphorus. There are around 8 acids are in your NCERT textbook. We have to discuss all of these acids deeply and clearly. So this topic is very important as your NEET and entrance examination point of view. So first of all, we have to remember two names of as phosphoric acids, phosphorus acid and phosphoric acid. From these two we can derive all other structures of phosphoric acid and the names, molecular formula, everything. Here we are going to discuss about the name and its molecular formula, structure, oxidation state and the basicity clearly. So if you know this topic, it is very easy to identify the structure, name, everything easily, and I am giving some clue everything. So we are going to discuss one by one. First of all, phosphorus acid. He3PO3 is the molecular formula of phosphorus acid. It's very easy. Hc3 is there, oxygen 3 is the one phosphorus. And if we go into the structure of this phosphorus acid, phosphorus 1 oxygen is double bonded with the phosphorus and one OH will be there in all the acid structures of phosphorus. One OH and CO double bond. So P double bond oxygen phosphorus with phosphorus. So it is easy to identify this structure. And here we have 3 hydrogen atoms and 3 oxygen atoms. So one oxygen already bonded with phosphorus by double bond and another we have remaining 2. These 2 oxygen always combine with oxygen, it form OH bond. So there will be 2 OH bonds are present. So extra one hydrogen is directly attached to the phosphorus. So this is the structure. Its structure is just like a tetrahedral shape. And going to the oxidation state of phosphorus acid, when one phosphorus is attached to oxygen, as we know oxygen is more electronegative than phosphorus, so one minus 1 charge is given to oxygen and 1 plus 1 charge is given to phosphorus atom. So here in pH bond phosphorus is plus 1 oxidation state. So in this way we can calculate the oxidation state of phosphorus in this molecule. So here oxygen is double bonded with the phosphorus, so there will be plus 2 oxidation state because of this double bond. And here OH bond is there. Here if we go inside, the bond is like phosphorus is attached to oxygen, then hydrogen is attached. So here oxygen phosphorus bond, there will be negative charge in the oxygen and positive 1 charge in the phosphorus. So how many oxygen atoms are there? 2 oxygen, plus 1 here, plus 1 because of this one. And here if we are going to pH bond, more electronegativity is to phosphorus. So here phosphorus will be minus 1 charge and hydrogen will be plus 1 charge. So around phosphorus the total charge is plus 2 here, plus 1 here, plus 1 here, minus 1 here. Total this plus 1 and minus 1 cancel, plus 2 and plus 1 is here. So the oxidation state is plus 3. So I discuss everything almost. And here OH bond, how many OH groups are there? 2 OH groups. So here in acids, this OH bond is more electronegative. Oxygen attract the hydrogen electron towards its side and easy to remove H plus ion. So the basicity depends upon the OH molecules which are attached to the phosphorus. So here the basicity is 2. So this about the phosphorus acid, very important. So from phosphorus acid, when we remove one oxygen atom, we are getting hypophosphorus acid. These three are comes under phosphorus acid. Here hypo means one oxidation state is less one is hypo. Here plus 3, here is the plus 1. How we will discuss this one also. So here on going to the structure, its molecular formula is one oxygen less than this phosphorus acid. It is H3PO2 only. So if we are going to the structure, I told you one CO bond and one OH bond is compulsory. So remaining there will be here one OH group is there, but here the O is removed. So here only hydrogen only in the hypophosphorus acid. So here see the structure is also same like a tetrahedral shape, and the going to the oxidation state there will be plus 2 because of double bond O. Here plus 1, here minus 1, here minus 1. So plus 2 minus 2 is cancelled, plus 1 only is oxidation state. Clear? So from phosphorus acid we find out by the elimination of one oxygen hypophosphorus acid. So comes here, if we add 2 phosphorus acid with the elimination of one water molecule, how we can bond this one? Suppose here 2 molecules are here. 2 molecules I have written. 2 OH groups combine together by the elimination of one H2O molecule. So there will remain one oxygen atom. This oxygen atom bonded together between 2 phosphorus. So the structure will be like this. Is it clear? Instead of 2 OH group, there will be one OH group only. One OH is transferred to oxygen bond by the elimination of H2O. This structure is known as pyrophosphorus acid. Pyro. Di, 2 molecules we are telling di. Instead of di we are telling pi. That's all. Pyrophosphorus acid. So here if we are going to the molecular formula, it is H4P2O5. Here from here we double this one minus H2O. So one oxygen less, 2 hydrogen less in the double of this molecule, it will be H4P2O5. Clear? So here when we go to the oxidation state, here we can count the oxidation state by here plus 2, here plus 1, here plus 1, here minus 1. So this 2 cancel, there will be 3 here. Same like here also plus 3 will be there. So total 6, but we have 2 phosphorus atom divided by 2. So the total oxidation state will be plus 3 in the pyrophosphorus acid. Clear? So phosphorus acid is over. Now we are going to phosphoric acid. What is the difference between phosphorus and phosphoric? One oxygen only increased here. So here the structure is H3PO4. There will be more 3 hydrogen atom by the 3 oxygen atoms are attached, 1 oxygen with a double bond. So 4 oxygen and 4 hydrogens are consumed. This is the structure, same like tetrahedral shape, and oxidation state is, we can calculate easily, it is plus 5, plus 3 plus 2 plus 5. So on going to the basicity, how much basic? This is monobasic only. Here it will be dibasic, right? Here it will be tribasic acid. Tribasic. Why? 3 OH groups are there in the atom. So I discussed the structure, molecular formula H3PO4, and the oxidation state is +5, and the structure is tetrahedral shape, and basicity is tribasic. So from this molecule we have to derive around 4 molecules, other 4 molecules. So first one is elimination of one H2O. Without adding 2 molecule we are removing one H2O. So here one OH is there. If we combine 2 OH groups, there will be H2O, one oxygen only remaining. So this bond also break. So with one negative charge, one oxygen will be there. This oxygen is highly reactive, and the structure of this molecule is like a trigonal shape, but it forms always dimer or trimer. Trimer or dimer structure, polymers, just like polymers. This molecule, one is attached here, one is attached here, and going like this. Otherwise this molecule will be present in a just like a benzene ring, and the phosphorus atom and the oxygen atoms are in a ring shape structure. And it is easy, but this structure, if they ask, you can write this structure only, it's okay. You have to put one arrow here. So here HPO3 only, H2O is removed, so here one H is there, and 1 oxygen also removed from the O4. So HPO3 is the molecular formula, and the name is metaphosphoric acid. Name is important. Meta, by the elimination only, metaphosphoric acid. So here when we discuss the oxidation state, it will be +2 here, here +1, here +1, total we have +4 oxidation state. +4 oxidation state is there. So next one is, if we add 2 molecules just like same as before, by the elimination of one water molecule, we are getting pyrophosphoric acid. Pyro, here also we use the dimer as pyro, right? So here the molecular formula will be H4P2O7. How it's here dimer, H6 will be the, we remove 2 hydrogen, so hydrogen is 4, 2 phosphorus will be there, 2, and oxygen H2O, dimer -1 oxygen, 8 -1, it will be 7. So the molecular formula is easy. Structure also same like before we discussed. OH group is combined here, 2 OH group instead of here 2 OH group will be there, 1 OH from this molecule, 1 oxygen OH will be from another attached by the oxygen bond. So we are getting like this structure. So here the oxidation state is +2 double bond here, +1 +1 +1, so it will be +5 +5, so total it will be 10/2 +5 oxidation state, 2 phosphorus, total 10/2. Okay, phosphor. So the basicity of this molecule is 4. 4 OH bond is there, tetra basic, tetra. Here it is tri, here it is only mono, here tetra, tetra basic. 4 OH group is there. So another 2 acids are from this one pyro. We can derive oxygen -1 oxygen atom. It will be this oxygen atom removed, and there will be direct phosphorus bond. So the name will be hypophosphoric acid. Hypophosphoric acid. Hypo by the elimination we get the before also hypo, right? By the elimination of oxygen it is hypo. So this oxygen we removed from the pyro structure, not from the oxo acid. This pyro acid dimer, we remove one oxygen, so we are getting hypophosphoric acid. So its oxidation state and structure are like this. Two O's will be there, one phosphorus and another two O's, double bond oxygen will be there, and the oxidation state here, one peculiarity is there is phosphorus bond. The electronegativity of phosphorus will be 0 0. This both have the same strength, right? So the oxidation state will be +2 total will be +4 oxidation state in one and 4 also other, so total 8/2 phosphorus oxidation state is +4, right? So here the oxidation state calculation by X, we are putting X as P, and for oxygen we are putting -2 and just like some calculations are there. You already studied in the +1 class, I think. So if you calculate the oxidation state of these some acids, it will be higher than we are expecting, and sometime it will be more than +8 +7 like this. So these are not acceptable. So in order to get the correct oxidation state of this type of acids, we have to go through the structures. Phosphorus bond will not be counted in some cases, and also some more cases oxygen per bond is there. Anyway, oxidation state calculation by this structure is better in these structures. Okay, remind that. And another important acid is from the phosphoric acid, we are eliminating one oxygen here by the elimination by from pyro. Here we are adding one oxygen atom. If we add one oxygen, it will be oxygen is included between the OH and phosphorus. So this acid name is phosphoric acid. Oxygen per double oxygen is attached together, so phosphoric acid, and the molecular formula will be H3PO4 is increased by oxygen number 1 and H3PO5, and the structure is like this, same like before phosphorus acid, but one oxygen is intermediated between phosphorus and OH group. That's all, very easy this one. And the oxidation state, +2 here, +1 here, +1 total there will be 5 +1 +5 oxidation state, and basicity is 3 OH groups are attached. It is tribasic acid, very simple. So how many acid we discussed? From the phosphoric acid, there are 2 hypophosphoric acid by the elimination of oxygen, and pyrophosphoric acid by the addition of 2 and by the elimination of 1 water molecule, and phosphoric acid H3PO4. From this one we will get by minus elimination of 1 H2O molecule, HPO3, and by the dimer by the elimination of 1 H2O, it will be pyrophosphoric acid. And another one type is from the pyro, we are eliminating one oxygen in this between this bond. That structure is hypophosphoric acid. Hypophosphorus and hypophosphoric, don't be confused. And another last one is by the addition of one oxygen atom to the phosphoric acid, we are getting this kind of one structure. In between phosphorus and OH group there will be one oxygen. Its name is peroxophosphoric acid. So we discussed these 8 kind of acids. First one is phosphorus acid. From phosphorus acid we find out hypophosphorus acid, pyrophosphorus acid, right? From phosphoric acid we found out pyro by the addition double, meta by the elimination of water, peroxo by the addition of oxygen. Hypophosphoric acid is derived from pyrophosphoric acid by the elimination of one oxygen. So these all structures and the name, molecular formula, oxidation state, basicity, everything I discuss very clearly. And okay, see you, bye bye, see you next video. And please subscribe my channel. If you like this video, please put a like button